All right, let's dive into a super important topic for your GCSE Computer Science exam: how to write code that actually works and doesn't just break. We're going to cover everything you need to know from Section 2.3 of the OCR spec, all about producing robust programs.
So here's our game plan. First, we'll figure out what a robust program even is. Then, we'll look at building our code defensively from the ground up. After that, it's time to go bug hunting. We'll learn about testing, the different kinds of errors you'll find, and how to choose the right test data. And finally, we'll wrap it all up with the absolute key things you need to remember for that exam.
You know the feeling, right? You spent ages coding, you finally hit run, and poof, it crashes. Or it just freezes. Or maybe it gives you an answer that makes absolutely no sense. It's so frustrating. So let's get to the bottom of it. Why does this keep happening? Well, the solution, and this is a core idea the examiners really want you to get, is to build robust programs. Think of a robust program as being, well, bulletproof. It's built to handle all the weird, unpredictable things real people might throw at it without falling apart.
So here's the absolute crucial point. A robust program isn't just one that works when you give it the perfect input. No, it's a program that's ready for the unexpected. It sees problems coming and deals with them gracefully instead of just giving up and crashing.
So how do we actually build these tough, robust programs? Well, your first move is to play defense. We call this defensive design, and it's exactly what it sounds like. You're building your code like a fortress from the very beginning, preparing for attacks before they even happen. And building this fortress really comes down to three things. First, you have to think like a user who's trying to break your program. What's the weirdest thing they could do? Second, you add authentication, like a username and password, to make sure only the right people get in. And third, you use input validation. This is like having a bouncer check every piece of data that tries to get in, making sure it's what you actually asked for. A massive part of defensive design isn't just about stopping users from messing things up. It's about stopping you from messing things up in the future. This is all about making your code maintainable. Think about it. If your code has clear comments, sensible variable names, and neat indentation, it's so much easier to come back to and fix later without creating new bugs. Trust me, readable code is robust code. Okay, so you've built your fortress using defensive design. But is it actually secure? You can't just assume it is. You have to actively try to find the weak spots yourself. And that, my friend, is the art of testing. The goal of testing is simple, but it's absolutely vital. Your job is to find the bugs before your users do. You are methodically, deliberately trying to break your own creation so you can find every single flaw and fix it. Now, when it comes to testing, there are two main ways to go about it. Think of it like building a giant Lego model. Iterative testing is where you check each little block as you add it, making sure it fits perfectly. Final testing, on the other hand, is like waiting until the entire Lego spaceship is built and only then checking to see if it'll fly. As you can probably guess, the best way to do it is a mix of both. Okay, so when your tests do uncover some bugs, and they will, they're almost always going to fall into one of two categories. For your exam, you absolutely have to know the difference between them. So a syntax error is basically a typo. It's a grammatical mistake in your code. The computer literally can't understand what you've written, so the program won't even run. A logic error, though, that's way more sneaky. The grammar is perfect, the code runs, but you've accidentally told the computer to do the wrong thing, so you get a weird, unexpected result. Right, this part is super practical and a topic that comes up in exams all the time. You can't just throw random data at your program and call it testing. Nope, you need a strategy. You need a proper test plan. This table right here, this is your blueprint for a perfect test plan that will get you top marks. You need to test 4 kinds of data. First, normal data, like the age 50, stuff that should definitely work. Then you test boundary data, like 1 and 100. Programs often break at the very edges of what's allowed. Next, you have to test invalid data. This is the right type of data, but it's out of range, like an age of 101. And finally, erroneous data, which is just the completely wrong data type, like typing the word 50. A great test plan hits all 4 of these. Okay, let's wrap this all up. We're going to quickly run through the absolute most important points that you need to have locked and loaded for your exam on this topic. All right, here it is. Your final checklist. Number 1, defensive design is all about preventing errors before they happen. 2, testing is about actively hunting for them. 3, know the difference between iterative testing, which you do as you go, and final testing, which happens at the end.
4, be able to tell apart a syntax error, which is a grammar mistake, from a logic error, which gives you a weird result. And 5, a brilliant test plan uses normal, boundary, invalid, and erroneous data. Get those 5 things down and you'll be in fantastic shape. And that's our look at producing robust programs. So the final thing to think about is this. How are you going to use these ideas, not just to pass your exam, but to make your very next coding project that much stronger, that much better, and truly bulletproof?